All right, so angle bisectors are basically when we draw a ray that bisects an angle. And remember, if you think about like segment bisectors, a segment bisector hits the thing at the midpoint, it splits it into two congruent pieces, two equal pieces. And so the angle bisector does the same thing, but for angles. All right, so if I draw a ray through the very center of an angle, and I split that angle to two congruent angles, two angles that are the same, well, that's an angle bisector. And so if I look at something like this guy, if this is an angle bisector, if this ray that's drawn there is an angle bisector, well, then that just means that angle 1 is now congruent to angle 2. All right? Those are the same if I have an angle bisector. That's what angle bisectors do. Okay? For example, if I look at this thing, it says find the measure of the angles. It says AB is an angle bisector. So now if I know that AB is an angle bisector, it means it splits the angle to two equal or congruent pieces. And so when I look at this thing, if this piece right here is a 27-degree angle, and AB is an angle bisector, splitting this thing into two congruent pieces, it means this piece has to be identical to that. So this also has to be a 27-degree angle. Okay? And so for this one, I can say that BAC, the measure of that equals 27 degrees. Okay? And that's it. I can just figure out the measurement of that angle based on the fact that, hey, this is an angle bisector. It splits it into two congruent pieces. I have one other angle here that I can identify, though. And that's the whole big angle, angle CAD. Okay? The whole angle can now be identified using angle addition. And so when I look at this, if I have two pieces that are the same and they're each 27 degrees, the whole thing is those two pieces added together. And so the whole thing is 54 degrees. Okay? So just knowing that thing is an angle bisector tells me, hey, I have two small angles that are the same, and I have one big angle that I can find through angle addition. Okay? If I look at something like these guys, it says, what angle would be needed to draw the angle bisector? And so for this one, I want to draw the angle bisector. I want to draw the bisector through this thing, all right? Which means I want to cut this in half. So the question is, what size angle do I need to draw that? Well, if the whole thing was 32 and I want to split this thing into two congruent pieces, it means that each piece would have to be 16 degrees. And so the question of what angle do I need to bisect this thing, the answer is I need a 16-degree angle. Okay? If I look at the next one, same kind of thing. If I wanted to split this thing in half, all right, if I wanted two congruent or equal pieces, I just have to look at this and say, hey, the whole thing is 127, but I want each of those little pieces if I draw the bisector. And so again, I just divide that thing by 2. Oh, sorry. And that's going to be a 63.5 degree. Okay, so what angle do I need to draw the angle bisector to split this thing into two equal pieces? I need a 63.5 degree angle. If I look at this one, same kind of thing. I want to split this thing into two congruent, two equal pieces. So just say, hey, to draw the angle bisector on this one, I need to split this up. And since this is a straight angle, since this is a line, it's 180 degrees. So if I split that into two equal pieces, it would each have to be 90 degrees. Okay? So the angle needed to draw the angle bisector is a 90-degree angle. And then this one, again, I've got a right angle here. And so again, if I want to split this thing perfectly into two equal pieces, well, I just take the 90 and say, hey, let's split it up. That's going to be a 45-degree angle for each. Okay, so the angle needed to draw the angle bisector, well, I need a 45-degree angle in order to split this thing into two congruent pieces. Okay?